Okay, just going to go through a couple problems here for you. So this first question gives you hypotheses that you want to test. The null hypothesis, pi equals 0.63. The alternative, pi doesn't equal 0.63. And then we've got a sample size here, and we want to use the Rossmann-Chance applet. So let's pull this up here. And so it wants you to report to 2 decimal places. So it doesn't ask you to round. What you did was round there. So pick one proportion. My sample size n is 700. In this case, they gave me 483 successes. So I'm going to put that here, 483. And it's going to calculate the p-hat for me. I want to do a test of significance. This area here, I need to put in my null and my alternative that I have over here. So I want to put pi equals 0.63, and then I want to put 0.63, and I need to toggle through here. This sign has to equal this not equal sign. So when I toggle through, I get not equal to, and it calculates. Okay, so down here it gives me my standardized statistic 3.29 and my p-value. So this 3.29, this 29 is 2 decimals of significance. So you wouldn't put 3.30, you want to put right here 3.29. All right, so that's an easy fix. Let's take a look at this one here. I want you to use the PowerPoint that I posted in Lumen. So we have the entire population here of a certain type of tree. Population, okay, has a mean height of 193 feet. Because we know, in this case it's known that the average of the mean height is mu equals 193. And the standard deviation of the population is 92.4. So what this question is asking then is it's saying, well, I want to collect a sample of trees. N equals 112 trees. So out of all the trees, I'm taking a sample of 112, and if I keep taking a sample and I create a distribution, okay, of means, so meaning there's a bunch of X bars here, so there's going to be a bunch of X bars. These are sample means, okay, all in here that I'm creating this distribution. And then it wants to show that each one of these tick marks is 1 standard error. So this is the mean, is the middle, and then I have 2 standard errors. Okay, so when I create this distribution and I do a theory-based approach, the center of the distribution is going to be mu, which you put here, 193. But because I'm taking a whole bunch of samples, on my pen, this distance here, we don't use that, okay? We're going to use this formula here from, let me see if I can pull it up, this sheet. Okay, so what I want you to be looking at is that we have one mean, and we're doing a hypothesis test, so to speak. And when I want to calculate the standard deviation of the distribution, I use this formula right here. Sigma or S divided by the square root of n. That is what that question is asking me. So how do I do that? Well, I want sigma over the square root of n. Here's my sigma, 92.4 feet. My n is my sample size, 112. When I divide that, I get a standard error of 8.73. So you must have done that correct here to get these correct responses. All right. This is a quick fix too. So I don't know what question problem this is, but what we can get in Rossmann Chance, we can get both a simulated, which is what we've been doing up to this point, a simulated p-value, and then we can get a theory-based p-value. And a theory-based p-value just means that, let's say we did it, our samples enough times that there's so many that this thing becomes exactly equal to a normal distribution. And if it becomes that close to a normal distribution, then we can use the formulas, the theory-based approach for formulas. In this case, what you have here, we have both combined. So we created a distribution assuming that pi is equal to 0.8. We have a sample size of 65, and then we repeated that 1,000 times. So these things here that are made up of dots, those are the simulated based approach. You put in your p hat here, and it's going to count all of the values that are greater than or equal to your observed statistic. All right, so when it counts it, your observed statistic was 0.8462. It counts out of all 1,000 dots, 234 out of the 1,000 equaled 0.2340. That's your simulated p-value. That's counting up dots. Well, what we also did here is when we select normal approximation, this solid stuff, okay, underneath that, that blue and orange, that is using the theory-based approach, meaning those formulas from the chapter. We get another p-value for the theory-based approach, 0.7195. So the theory-based approach says 0.1759. So they're really coming up with the probability of getting a statistic greater than or equal to our observed statistic, but one is using this simulated approach and one is using the formulas, a theory-based approach. You can see that they're different. They're still both pretty big. So when we come down here, the p-value from the theory-based means I want to take this one down here because I used a normal approximation. So it's not this value here came from adding up how many dots out of 1,000. This one here is my theory-based approach. It used that formula to come up with the p-value. So it's using this information here, okay, to come up with a p-value, all right? But you get both of them in the same graph. So because both my p-values, though, are pretty big, I have my simulated p-value is equal to 0.1759, and my theory-based p-value, that's not confusing, is oops, I have it backwards. This one is my theory-based. Sorry about that. This one is my simulated, was 0.2340. All right, did it give us, well, if it doesn't give us anything, we're going to use a 5% alpha. Alpha equals 0.05. Both of these are way bigger than 0.05. So if it's bigger than 0.05, p-value greater than alpha, okay, so 0.1759 or 0.2340, both of these are greater than 0.05, meaning the null is plausible or the null is believable. And we can see this here as well, right? This is where my observed statistic is. It's pretty close to the middle. It's not way out in the ends where it would be unusual. Okay, so this means that it is plausible that the null is true. What was the null? The null said that pi equals 0.8. Okay, so it is plausible that the true population parameter is pi equals 0.8. This is the null right here. Okay, this one down here would say that pi is equal to my observed statistic. That's not true. Okay, not greater than, because p-value is greater than alpha, the null is plausible. What is the null? Here's the null up here. Pi equals 0.8.